to this, our last session together. Mathematical Practice 6, Attend to Precision. To meet the goals of Mathematical Practice 6, pre-K to grade 2 students need to be learning to use mathematical vocabulary when they explain their thinking, use correct numbers and symbols when they reason quantitatively. They are to use correct numbers and correct symbols when they speak and when they write. Students are to listen to others to understand precisely what others are saying, and they need to understand written numbers and symbols. Math is a language, and like any language, math language builds with precision. For example, if we look at the CCSSM, we see that in pre-kindergarten, students learn the precise number sequence from 1 to 10, and then in kindergarten, children learn that sequence up to 20. Pre-kindergarten and kindergarten children need to be precise in their recognition of written and oral number names. Then, in grade 1, students learn the plus sign for addition and the minus sign for subtraction. They learn what the equal sign means and what the symbol 0 represents. In learning these symbols, students need to be precise in their understanding and in their communication. The purpose for any language is to communicate with meaning. And like any language, math language is associated with meaning. Grade 2 students won't know what 2 plus 2 means if they don't know what a 2 is or what plus means. They might memorize that 2 plus 2 equals 4, but without associating each number and each symbol with precise meaning, 2 plus 2 equals 4 holds about as much meaning as teaching a parrot to say, "Polly wants a cracker." Like all other languages, math language requires fluency. The building of vocabulary starts in pre-kindergarten, where students learn to use words like tall and short, big and small. They learn comparative words like taller, shorter, bigger, and smaller. Yes, students are adorable when they invent their own words, but we need to resist the urge to let them continue using these incorrect, though humorous words. We teachers need to let children know that we expect them to be precise in their use of math language. In the assessment for this module, the transfer learning assignment will be to analyze the pre-kindergarten through grade 2 standards. And in analyzing these standards, you'll be looking for the precision expected at each of these grade levels. In this module, I occasionally compare across grade levels as examples of what you will be called on to do in the assessment. Attend to precision. As this poster suggests, Mathematical Practice 6 points to the need for students to be careful and clear when they're communicating their ideas, communicating their mathematical thinking. They need to be able to use precision when solving problems, and they need to use precise words when communicating ideas. We learn to attend to precision. Think back to your own schooling. I think you would agree that most, if not all of us, were taught to use precision when calculating answers. Our teachers looked for correct answers. Unfortunately, though, sometimes they asked for just the correct answer, regardless of whether we understood what those answers meant or not. We became so accustomed to not looking for meaning that we no longer questioned what something meant. And we often assumed that the only reason for learning math was to pass a course, because we figured we'd never actually use the math that we were learning. For a case in point, think about algebra. We could work out algebraic equations by using BEDMAS or PEMDAS or some other acronym for coming to the correct answer. But do you know why you need to perform algebraic equations in a certain order? Or better yet, even if you can still solve an equation like 2 times x plus y times x minus y minus x minus 2y. You could solve it, but do you have any idea where you might use this in your life? Did our teachers even know where this might be used in real life? We settled for the conclusion that if our calculation was correct, that was good. If our calculation was incorrect, that was bad. We learned to attend to precision. We may have learned to calculate efficiently using quick ways to find answers. For example, because you know that 5 plus 5 equals 10, you may use that understanding of doubles to figure out that 5 plus 7 is really 5 plus 5 and 2 more. You may use efficiency when you're adding 20 plus 23. If you do use efficiency, you probably added from the left to the right rather than the right to the left. When students attend to precision, they check to make sure that their answer matches what the problem is asking. Do I find the exact answer, or is precision in a particular situation an estimate? Consider the following example. Our class will travel in vans to visit the zoo. A van holds 4 children. How many vans do we need for our class of 15 children? The calculated answer is not the precise answer for this situation. The calculated answer is 3 3/4, rather than the precise answer which is the estimated answer of 4 vans. For other examples, donuts come in dozens, cookies and juice and packages of so many cookies and so many boxes of juice per package. Even before children learn to divide using the division algorithm, they can attend to precision through various other means that make sense to them. Yes, math is a language. In essence, when you're teaching math, you are a language teacher. And like teaching and learning any language, if we are to communicate in that language, we need to build vocabulary. And if we are to be understood and understand, we need to be precise. If you said to a child, "Bring me a shoe," that child would need to know what a shoe is. In like manner, if we say to a child, "Bring me 2 of something," that child needs to know what a 2 is. Like all languages, math language is composed of words and symbols and numbers. In the days before the CCSSM, many classrooms viewed math as primarily a language of numbers and symbols, whereas the CCSSM has brought back to mathematics the language of words and vocabulary and speaking and writing and listening with meaning and comprehension. And yes, that includes numbers and symbols, but so much more. I hope as a result of this module, you will view math as a language of precision. And I hope we will fully grasp how essential it is for both students and teachers to attend to mathematics as a language of precision. This table is from the website called All Things Common Core, where a blogger, Michelle F., and a team of teachers composed this table to better envision what mathematical practice 6 looks like in the classroom. They call the table a work in progress. I'm happy to say that I saw many of these ideas being practiced in your tutor sessions. As we read through the table together, you will hopefully consider some additional ideas to promote precision of language with your own students. Let's look at these together. Student actions. To promote precision, students talk with one another using correct math vocabulary. They could keep vocabulary journals that allow an interaction with math vocabulary through pictures, drawings, and students' own words. They use correct terms and are able to give examples and non-examples. Children can play games with math vocabulary words, games like concentration, horse, make a sketch. Students use correct labels with word problems. Other student actions include using math vocabulary and explanations that help them to clarify their thinking, and focus on clarity and accuracy of processes during problem solving. Teachers' actions that lead to precision include the following. We intentionally and purposefully use the correct vocabulary terms in our own speech when we describe the world around us. For example, instead of saying run around the gym, when we teach older children, we would add, please run the perimeter of the gym. Around the gym is a good vocabulary word to use with lower elementary. Use the activity I have, who has, using math vocabulary words. For example, I have a square. Who has a circle? We are to provide time for students to keep an interactive dictionary. Another action we teachers can follow is to allow time for students to formulate and explain their ideas to other students, to the class, and to us. We can ask students to provide a label with solving word problems. For example, when solving a word problem about hats, rather than accepting the answer for, we require that students answer for hats. We can facilitate discussions and explanations using probing questions. And we can provide a space for students to create math word walls that can develop throughout the year as a math word is introduced. To promote precision, we can also use open-ended questions, as you've done in many of your tutoring sessions. We might ask, how might you explain the problem in another way? Or, what math words have you learned that you might help explain your thinking? Or, how would you describe the problem in your own words? What words from your vocabulary journal, from an anchor chart, or a word wall might help you to describe your thinking? Questions like, how do you know? We might ask students, what are some examples and non-examples of this word? What mathematical word might we use when we describe this process? Or we might ask students, how might your math vocabulary journal help you explain your thinking? If you're interested in a book full of child-friendly lessons, games, and activities aimed at the mathematical practices we've been studying in this module and in this course, see the reference slide below for a book entitled Engage in the Mathematical Practices. This book, written by Norris and Schul, written in 2016, is now in the Niagara University Library. Teachers need to attend to precision. When teachers fail to attend to precision, students build misconceptions. Some of the ways that teachers fail to attend to precision are as follows. When teachers overgeneralize commonly accepted strategies. When we use and accept imprecise vocabulary. When we rely on tips and tricks that fail to promote conceptual understanding. We will discuss these three ways in the upcoming slides. Much of what we will discuss comes from the article 13 Rules That Expire that are written by Karen Karp and colleagues. Dr. Karp and her colleagues have written numerous books for elementary math teachers. In the past, she wrote with the distinguished author Dr. Van de Walle, who passed away just a few years ago. Dr. Karp has continued the work that Van de Walle began. Rules that expire. As you realize, the CCSSM calls for deep comprehension. Because your math education and mine was not based on such rigorous standards, it's easy to see why we may still have some of the old ways of thinking about math. We may explain things to students in ways that we were taught without analyzing whether that way of thinking is really true. Karen Karp, her article addresses this very issue. In the article, she includes rules that pre-kindergarten and grade 2 through grade 3 teachers might be teaching their kids. Rules that Karen Karp calls expire. She calls it rules that are not always true. These are rules that at the moment seem true, given the present context, but that are not always true, given other contexts. Some of these so-called rules are taught as clue words that teachers tell students to look for in a problem. We talked about these in a prior module. Perhaps you remember our discussion of rules or clue words like altogether that doesn't always mean to add, and difference that doesn't always mean to subtract. Karp talks about memorization tricks that are not always true. She emphasizes that clue words and memorization tricks in the end confuse children because they rely on these so-called rules rather than building understanding, rather than attempting to comprehend. For example, when a grade 1 teacher teaches children the rule, when you add, you join two groups together, that teacher is teaching a rule that expires. I can't tell you how many times I've seen teachers teaching that so-called rule. That rule expires in grade 2 when students learn to use adding to compare numbers. For example, consider the word problem, Joe has 3 books. Tim has 2 more books than Joe. How many books does Tim have? Comparing and joining hold 2 different meanings. And yet, both meanings are associated with the addition algorithm. Comparing 2 quantities is quite different than joining 2 groups of quantities. Precision is critical in pre-kindergarten through grade 2, where students are building a foundation upon which all learning will rest. Precision avoids the building of a cracked foundation. Let's look at precision a little closer. Look at the equation on this page. Karp gave children these equations and asked them what the equal sign means in the equations. What do you think children said? Take a minute to think about this. In their study, Karp found that most of the children that were asked thought that the equal sign means to find the answer. Children think this because we teachers say things like, "What is the answer?" or "Find the answer to these problems." You may be asking, what then does the equal sign mean? If we are to teach children what the equal sign means, we need to know what it means ourselves. As teachers whose teaching rests in the CCSSM, it behooves us to re-examine our own understanding of the words and the symbols used in math, remembering that math is a language, remembering that our learning of this language may not be as developed as it should be, and remembering that math language, like all languages, needs to convey precise meaning. We use the equal sign all the time. What does this symbol show? Think about it. What does it mean? The equal sign shows a relationship. The equal sign means that there is a relationship between the quantities on either side of the equal sign. There's a relationship between the quantities on the left side of the sign and on the right side of the sign. As I hope these pictures suggest, the equal sign means that the quantity before the equal sign and the quantity after the equal sign are balanced, are the same. Quantities being compared are the same quantity. Some teachers help students understand the meaning of the equal sign by using a balance scale. As the bottom right of the slide suggests, the equal sign is one of 3 signs that show relationships between quantities. The other 2 signs are used to show that a relationship between 2 quantities are unequal. The first sign shows the quantity on the left side of the sign is greater than the quantity on the right side, and the second relationship sign shows that the quantity on the left side of the sign is smaller than the quantity on the right of the sign. Another common rule that expires happens when we teach students to compare shapes. The rule that expires is taught when teachers ask how shapes are similar. This rule expires in later grades when students learn about similar shapes. In precise language, the word similar means the same shape, but not the same size. Use precise language. Rather than teaching a rule that expires, ask, how are these shapes the same? How are the shapes different? These next 3 slides give a brief overview of Mathematical Practice 6. When teaching, attend to precision to avoid student misconceptions that will need to be unlearned. Purposefully teach math vocabulary to help students learn the language of math. In review, as a teacher, I communicate clearly with clear definitions. I help make the connection between vocabulary, student thinking, unit labels, and calculations. As a teacher, I emphasize the importance of precision in all domains, including counting, base 10, algebraic thinking, measurement and data, and geometry. And I encourage the use of math vocabulary during conversations, student to student, teacher to student, student to teacher, and teacher to teacher. Also in review, we teachers need to expect students to calculate with accuracy and efficiency. We expect students to use the correct labels, symbols, and terminology, to talk and give explanations using correct vocabulary. We expect students to use precision in all domains, including counting, base 10, algebraic thinking, measurement and data, and geometry. And we expect students to think with clarity about the process of problem solving. Finally, in review, we teachers should ask students to explain how they solved the problem. Ask students if they think they use the most efficient way to solve the problem and why they think that. Ask students what different symbols and vocabulary words mean. As you did in your tutor session, have students explain how they know their answer is accurate. Ask students what mathematical language, terms, definitions they can use to explain their thinking, problem solving, their confusion, their conclusions. And ask students what labels they could use to communicate more precisely. For this module, the transfer of learning will require attention to precision in the unpacking of math standards into teachable curriculum. Each of you will choose a subtopic from the pre-K to grade 2 standards. With attention to precision, you will develop teachable curriculum. The subtopics from which you will choose are found on the next slide, and how to unpack standards into curriculum is found in the next 10 slides. On this slide are 6 choices from which you will choose a topic to unpack. This is on a first come, first served basis. As it says in red at the bottom of the slide, email me to find out which options are still available. We refer to the content standards often throughout the course, and you use the content standards when you plan for what you are going to be teaching your students. In this module, the last in the course, we looked at the content standards through the lens of Mathematical Practice 6. In terms of precision, what do the standards expect students to know, understand, and do in pre-kindergarten, in kindergarten, grade 1, and grade 2? To determine this, as a class, we will unpack the standards from pre-kindergarten to grade 2. Each of you will contribute to this unpacking. And in the end, I will put your contributions together into one PDF document for you to download. At this point, you may be asking, why do the standards need unpacking? What does it mean to unpack a standard? And how do I unpack a standard? My goal in the next set of slides is to answer these questions. Why do standards need unpacking? Well, the standards themselves attest to the fact that they are not curriculum. They are not the specific concepts, facts, understandings, skills, in other words, curriculum, that students are to learn. On page 5 of the math standards, the CCSSM clearly states that it's not curriculum. It says, these standards do not dictate curriculum. CCSSM is, rather, a set of benchmarks, a set of goals for what students are to learn at each grade level. And as we talked about earlier in the class, as such, standards need to be decoded, interpreted, unpacked for meaning. As Wiggins and McTee state, a standard has to be treated like any other non-fiction text. We have to carefully analyze and interpret its meaning. What does it mean to unpack a standard? What does it mean to analyze and interpret the meaning of a standard? Ainsworth defines unpacking as, unpacking means analyzing and deconstructing the wording of grade level and course-specific standards within each unit of study to determine exactly, precisely what students need to know, the teachable concepts, and what students should be able to do, the specific skills. To unpack means to turn benchmark statements into math language, into precise words, pictures, diagrams, and examples that decode exactly, precisely what students are to learn, are to understand, and do. You may be asking, how exactly do I analyze and unpack a math standard? How do I interpret from the standards the precise concepts, the precise language, in other words, the precise curriculum that students are to learn? Following is my attempt to take you through a step-by-step process for doing just this. In this slide, I give an overview of the steps, this slide and the next slide, and then the slides that follow, I will apply those steps to one topic. So, to begin, an overview of the steps is as follows. Step 1, locate the standards you will unpack. Locate the benchmark statements for what students are to learn about your chosen topic at a particular grade level. Step 2, identify the vocabulary. That is, identify the key words and the terms in the standard that represent teachable concepts. In other words, the content that students are expected to know and understand, and the skills that students are to gain at that grade level. So, locate the standards, identify the vocabulary. Next step, formulate questions to guide your research. You will need to research in professional journals to determine and to understand the knowledge, understanding, and skills yourself. As the saying goes, you can't teach what you don't know. Step 4, locate and study professional content resources. Research using professional resources. That is, find your topic in books and journal articles. Internet sources are not professional resources. You'll need to research to find out what you do not yet know. You'll need to research to find out what you do know that needs to be broken down into smaller concepts, into smaller bits of information. You need to research to become aware of the precise language to use when teaching concepts. With the questions you formulated in Step 3, go to the professional math books and study these to build your own understanding. For this course, I put professional math books on reserve in the Niagara University Library. As I mentioned before, be wary of internet sources, as most are written by non-professionals who emphasize calculations or answers, who use clue words, who use math language incorrectly, and who emphasize finding answers as opposed to building understanding. If you are not near campus, I suggest you go to a university near you that has a teacher education program. At the end of this PowerPoint is a slide with a bibliography of books that I put on reserve for you at Niagara University. Check with the university library near you to see if they too have these books. When you find one of the books on the shelf, notice the books around that book and let these serve as your set of professional resources. So, we have located the standards, Step 1. Step 2, identified the vocabulary. Step 3, formulated questions. Step 4, located and studied professional content resources. Our final step, then, is to translate key concepts and skills into student-friendly words, diagrams, and examples. Work methodically at translating your research into simple terms that even the lowest level performing students will understand. In the following slides, I go through how to use these 5 steps using a specific topic. The topic I've chosen is compare relationships between quantities. To make this next part the most meaningful, I suggest you stop the video or the MP3 recording and you access the CCSSM standards before you proceed to the next set of slides. You can download the document from this module on Canvas. Before moving on to the next slide, attend to Step 1. In the CCSSM, locate the standard that you will unpack. Looking at the CCSM document, looking at pre-kindergarten to K, what standard do you think will address my topic? Again, my topic is compare relationships between quantities. You may want to pause the video here as you locate this standard. So, Step 1, you were to locate the standard that will be unpacked. Did you locate the pre-K standard PKCC5, which states, identify whether numbers of objects in one group is more, less, greater than, fewer, or equal to the objects in another group, up to 5 objects. You might have considered PKG standards where students compare relationships. However, in these geometry standards, the comparisons are not quantities. They're other than quantities, so we bypass those standards. We conclude that the only pre-K standard that focuses on comparing relationships between quantities is PKCC5. Having completed Step 1, we move on to Step 2. Identifying the vocabulary. Before moving on to the next slide, I encourage you to jot down the precise vocabulary pre-K students are to understand. For step 2, did you note the vocabulary words more, less, greater than, fewer, and equal as the words for which students need to develop precision? Moving on to step 3, formulate questions to guide your research. Think about going to professional resources, and what would you be looking for? What questions might you formulate for these vocabulary words? How can we make these words precise? I might start out with the following list of questions, realizing that when I research using professional resources, I may come up with yet more questions. One of my questions is, what is a relationship? What does quantity mean? What does amount mean? If students understand the meaning of the words more, less, greater than, fewer, and equal, what exactly do they understand? Step 4, study professional content resources. When we do this, we can look in the table of contents and find chapters that may be related to our topic. Look in the index for specific words, and study. Not just read, but study. Notice the diagrams, the bold type, the general and specific connections to the topic. And then in step 5, translate. I now need to take the results of my careful, meticulous, comprehensive study and express what I found in language that pre-K children will understand. I need to use student-friendly words, diagrams, and examples. And in doing that, I need to keep precision at the forefront to ensure that I'm not teaching students rules that expire, rules that may be fitting for a short term but that confuse in the long term and that lead students to misconceptions. See the next slide for my beginning work for step 5. In this slide, you will see I unpack curriculum for my topic, which again is compare relationships between quantities. This slide shows only a part of the unpacking I've done for comparing relationships between quantities. Notice the precision in the words chosen to unpack and in the definitions for each word. Notice the vocabulary words amount, compare, and greater than, and how they're defined. Notice that each bullet has only one statement or one fact, one per bullet. That's what I'll be looking for in your unpacking. Notice the heading, greater than. And notice that within that heading, it takes a number of one bullet statements to convey the meaning for that one term. Notice that the words used are child-friendly. These are words that a pre-K to grade 2 student would understand. Notice the use of examples. And notice the use of diagrams or pictures. This is the format I will be looking for in your unpacked curriculum. In the next slide are the topics we will unpack this semester. Each of you will unpack only one of these topics. The first person to choose a topic has the first choice, the second person, the second choice, and so on. When you get to this place in the semester, email me to see which topics are still available. You may wish to unpack pre-kindergarten and then add to that unpacking for kindergarten, grade 1, and grade 2, as I have done. Or you may wish to go through steps 1 to 5 for all grades at one time. One way can be just as effective as the other. The choice is yours. In these last slides, I compare my topic across grade levels. To review what we've learned up to this point, pre-kindergarten students learn to compare relationships between quantities. In their comparing, they learn to use precise vocabulary like more, less, greater than, fewer, and equal. They compare quantities up to 5 objects. When we look to the kindergarten standards, we see that students build on what they learned in pre-kindergarten, this time comparing quantities and numbers up to 20. The vocabulary is the same, the quantities increase. To continue our comparison across grade levels, find grade 1 on the chart. As you remember, grade 1 standard starts with a 1. In grade 1, students build on the understanding of comparing relationships between quantities. If the foundation for making comparisons and using comparison words was not built in pre-kindergarten and kindergarten, the grade 1 teacher needs to fill that gap, needs to ensure that students have the foundation upon which to build an understanding, and needs to ensure that students have that before they introduce the equal sign, the greater than, and the less sign. Also in grade 1, students learn to compare lengths, and they learn to order objects by length. In grade 1, students are to gain the foundation for fractions by comparing parts of whole objects to whole objects. For example, half of shows a comparison relationship between a whole and one part of a whole, with that whole being partitioned into 2 parts. Precision is key. Precision in curriculum unpacking, precise expectations, precision in language, teaching to precision, and expecting students to be precise. The vocabulary for showing relationships between quantities is precise, and that precision of language and meaning is a foundation laid in pre-kindergarten and kindergarten, a foundation that is then built upon in grade 1 and beyond. You will notice that I listed the standards for pre-K to grade 2. Due to lack of space, I didn't include all of the grade 2 standards that include comparisons. For grade 2, all comparisons built on prior grades are extended to quantities up to 100. Comparing amounts using standard tools like rulers and standard units. Grade 2 students progress to fractions 2/3 and 2/4, and they compare wholes of different shapes. Just as I listed the standards and then unpacked the precise vocabulary for those standards, in the assessment transfer for this module, you will do the same sort of sequencing from pre-kindergarten to grade 2 and the same sort of curriculum unpacking, only you'll do this for your chosen topic. On this slide is a set of professional resources to get you started in your unpacking. For most resources, I listed the most current editions. However, I have found that earlier editions are just as helpful. At NU, I put most of these books on reserve. Simply ask the person at the front desk and you can see the books that Dr. Sianka has on reserve. If you can't make it to the Niagara University, as I mentioned earlier, go to a nearby university that has a teacher education college. Notice the books stacked near the ones I have listed, as these should also prove helpful. I think you will find Unpacking for Precision a valuable exercise, one that will give you the skills you need to teach your students the understanding required by the CCSSM. With this skill, you will build in your students the solid foundation